you guys know me. I've been here a couple times. I'm Richard. Nice to meet you. So basically, I saw this guy on Twitter and online who had basically built like this gaming lab, like a LAN party thing at his house. He had a whole bunch of computers sitting in a rack, and he ran HDMI cables and USB cables from his basement to like this awesome living room where it had in the walls like flat panel TVs, keyboards, mice, monitors, all that stuff, and like one big TV in his like living room where you could watch like StarCraft tournaments and like 8 people in a room all participating in some frag fest. Awesome. But yeah, so basically I'm going to cover really quick how you can boot Windows boxes or Linux boxes completely off the network without a hard drive in that computer. So basically, if you aren't this guy, and that's Jason Scott at the Internet Archive, and you have one of these, you might be a digital hoarder. I have one of those at home. It's a 24 something bay SAS enclosure. It's 6 gigabits per second, and I have about 20 disks in it. So yeah, I think I have a problem. Anyways, so yes, he is. So basic requirements. So I'm talking about booting computers off of the network, and your computers at first are going to need some way to get an IP address. So you're going to need a NIC that supports PXE. PXE is pre-boot execution environment. It's kind of how SCCM or any other like imaging system like Ghost kind of works. So you'll need a DHCP server to hand out the IP addresses and a couple extra parameters, a TFTP server that the PXE boot ROM in your NIC will talk to download stuff from, and optionally a web server so you can download more stuff, and a couple of apps. So iPXE is an open source PXE boot ROM replacement. You can actually load that from the PXE boot ROM that's in your NIC's boot ROM or in your computer motherboard's BIOS over the network. I used Linux LVM, the logical volume manager, to contain my disk images, and I used iSCSI to export those disk images across the network. And you need an OS that supports iSCSI boot.
You also need perfect physical security.
Sure, yeah, like this is at my house. So yeah, totally I could have someone who just like jacks in and starts TCP dumping my iSCSI stuff. Go ahead.
Is the iSCSI boot actually a requirement, or is it an optional and I can switch it out for like ATA over Ethernet or something like that?
Okay, yeah, you could use ATA over Ethernet, but from what I read, ATA over Ethernet is actually less secure than iSCSI. iSCSI, you can actually do like client talking to the server, here is my password, and then the client can actually verify that the server it's talking to actually has another password that it can like double check. It's not like certificate authentication, but there's a way you can have both sides authenticate each other. Yeah, chat, yeah. So the boot process. Everyone's seen this. Your computer boots up. It does the power on self-test. It looks for a local hard drive or CD-ROM drive, USB thumb drive, something. If none of that is there, chances are it's going to try to boot off of the network. At that point, the PXE ROM says, hey, I'm initializing. I'm going to fetch a DHCP lease. It asks the network, I want an IP, and it says, I am a PXE boot ROM. I am trying to boot off of the network. There's stuff embedded in the DHCP lease that says, I need to know what to do next. So at this point, it's going to ask the DHCP server, where do I go to download and execute a small program? This could be your copy of iPXE, which I'm using here, or it could be your Wim boot for SCCM. Or optionally, if this boot ROM just completely knows iSCSI or ATA over Ethernet on its own, you can point it directly at some network file system URI, like an iSCSI drive or an ATA over Ethernet drive, and it just goes from there and boots. Done. Or you can just have it load some program. You can actually load DOS.com files over PXE. It's called comboot, and it just magically works. I don't know how, it just does. So DHCPD, basically inside of there, there's an options setting where you can say next file, and that's what your PXE ROM is going to download and execute when it comes up. the root path. If you have it configured to talk to your iSCSI or ATA over Ethernet server, that's how you tell it to get to that root file system. And next server is where your file system is on your network. TFTPDD. So this is under your XINetD daemon on your Linux box. You want to go in and enable it. By default, I think it's a security thing in most common Linux distros. It has all the services disabled, so you actually have to go into etc xinetd.d and find that tftpd file and edit the line that says disabled equals yes, and change that to disabled equals no. And you start putting your little images you're going to boot in your tftpboot directory. It's either /tftpboot or I think var lib tftpboot on later versions of Red Hat. And you need to make sure that they're world readable, because basically you're going to have any system on your network that's trying to read files from here, but you don't necessarily want it to be world writable. Yeah, that could be bad. But I mean, some of your guys that are running like Cisco switches and stuff where you can save off your configs over TFTP, like in some cases you do want that to be writable. Anyways. So PXE booting, like I said, it's used in SCCM. You can also use it in PXE Linux, which is a kind of network boot fork of SysLinux. That's what I used to use, and then I found out how awesome GPXE and iPXE are. Both of those were originally projects of etherboot.org, which was the open source boot ROM replacement stuff. iPXE is the most feature rich. GPXE has basically slowed down, if not died, on development on there, but iPXE is taken off like a rocket. So if you're using the iSCSI DHCP daemon like I am at home, you can load iPXE over the network, and this is how you do it. Basically you say if the user class, which is an option in that magic PXE boot ROM DHCP request, contains a special identifier called user class, that's iPXE, then it gives it the iPXE configuration menu file. Otherwise, it sends a generic replacement iPXE executable over the network to your plain Jane, whatever your PXE boot ROM is. So this is how you go from your regular boot ROM to loading iPXE and then loading an iPXE menu. This is some kind of scripting you can do in the iSCSI DHCP daemon. Next up, you got to have your iSCSI target configured of where you're going to have things going to, and it's really this simple. You give it a target, this IQN name, which is basically IQN dash some year and month, and then basically your domain name backwards, like Java class files, and then some descriptive name. So I've got com.example.sam and then Linux for the Linux iSCSI. And then where that actually writes to on your iSCSI SAN server. So I've got a volume group called SAN, another I've got a logical volume called Linux. And I found out that having write caching on is a bad thing if you try to talk to this hard drive locally on that SAN server itself. Like, for example, you wanted to mount a disk image read-only to inspect it while a system on the network is talking to it. If you have write caching on, the target daemon will have those bytes written to disk still cached in memory instead of actually having it written to disk. So you'll get things that are out of sync. So that's why I turn it off. And then how to get that iSCSI drive to show up via iPXE. Basically what iPXE does, it's the same thing as like your SCSI controllers used to do back in the day. There'd be a little boot image in that SCSI controller that says, "Dear computer at hex port 80 or 81, whatever, here is some code on how to talk to this hard drive that you don't know how to talk to." It makes your bootloader or DOS or anything that doesn't understand this have a basic BIOS-assisted way of talking to this drive. So this is the initial way of getting it there. So you tell iPXE either on the iPXE command line or in that iPXE script I mentioned earlier. You say sanboot, iSCSI, the server, which could be a host name or an IP address. That number 1 there is the like SCSI target ID, because you know you can have multiple devices in SCSI target, and this basically is SCSI just over the internet. And then that path I showed you earlier, so your IQN year, month, combat example, and then your share. And it's the same command for both Windows and Linux. Shoot.
So I see all those colons up there. Does it support IPv6 somehow?
So those are delimiters. The other things in there are the port that you're going to talk to.
I mean, could you shove a V6 address in there, and how would it know what's not a delimiter, what's not part of the address? I'm just curious if you came across it. If you didn't, I'm not.
I think iPXE doesn't support IPv6 right now, but I think they're doing a Google Summer of Code project where they're adding it in.
Oh, okay.
And they're also doing other really interesting stuff with like talking to the PCI bus to enumerate like devices that are inside the machine. So you can do like, oh, this is an HP server. There, it gets the HP image. That sort of thing. Same SAN boot command for both Windows and Linux. And iPXE scripting. So this is how you're going to actually do cool things in iPXE. I actually have a menu interface at home where I've got, I want to boot Linux on this box. I want to boot Windows on this box. I want to install Linux to this machine's local hard drive. I want to install Linux to an iSCSI drive. I want to install Windows 7 to an iSCSI drive from an ISO I have on the remote server. All of this stuff completely diskless. It's really sweet. So iPXE supports a whole swath of different protocols to download stuff. TFTP, HTTP, HTTPS, FTP, NFS, and you can also use ATA over Ethernet, iSCSI, InfiniBand, or Fiber Channel. And for computers that really have no hard drive in them, like this guy, you can even do PXE boot over wireless if you can hack in iPXE into your BIOS. It's actually possible. You can hard code in your SSID and your password there, and if this thing, its hard drive got nuked, I could reinstall it. So installing things to iSCSI. With Windows XP, it's kind of difficult. It doesn't really support it out of the box. If you put a lot of effort into it, it can be done. There's these things called RISC-compatible network card drivers, which if you've ever done SCCM or anything else with Windows deployment, you will learn very quickly that finding these RISC-compatible drivers is a pain. And if you have any machine that has an NVIDIA Enforce forced Ethernet driver, basically RISC drivers don't exist for that platform at all. So basically, you basically have to install to a hard drive first, install the Microsoft iSCSI initiator, and then install a thing called a SAN boot driver, and then just copy your disk image over, and it works. That's how I got XP netbooted at home. Windows Vista and later, a lot easier. That whole thing where you do SAN boot and then the iSCSI URL, there's a way to tell the BIOS on the computer, don't actually try to boot from that drive, but just make that drive available. So when you get to the point of where your OS installer is checking to see what actual hard drives are around, it sees it. It just magically sees it's there. And Linux, trivial. You basically just punch in that URL or the SAN hook command there, it just shows up. For versions of like Fedora, like 14 and onward, it just works. Oh, sorry, question.
Do you know if the situation changes, hopefully for the better, with the like UFI BIOS stuff as opposed to old legacy BIOS?
So I got a brand new machine at home, and that's what I'm using this on. It's an Asus machine with EFI BIOS, and the UEFI PXE boot ROM. It's supposed to announce to like the DHCP server, hey, I'm UEFI, because if you try to load a standard PXE boot executable to UEFI, it's like, sorry, no, can't do it. No, don't go to sleep. Yee.
Appears to be the magnify command on Windows.
Come back. Once more. There we go.
VGA virus.
Yeah. First it was John's laptop. All right. Go back. Don't be at the very beginning. It is. Yeah, button mash like Super Street Fighter. Ah.
While Richard's
Okay.
following the slide, the other thing to watch out about with DHCP is if your DHCP server is running on like your firewall or a machine, and your TFTP daemon is somewhere else, you generally have to set an option
Next server.
that's different, because some devices only want to, they automatically look at the DHCP server for the TFTP server as well.
Yeah, they'll default to the server that handed them the lease. So why am I doing this? I wanted to play with virtual machines, just having them install without any configuration on them besides you have RAM, you have CPU, you have a NIC, and you have video. That's it. And I also wanted to play with snapshotting bare metal machines hard drives, which is kind of hard to do with SATA or SCSI or IDE. But now I've got this thing over the network where the hard drive is a logical volume on another machine where I can snapshot it as much as I want. Do not go to sleep. So now I can roll back malware infections. The only time I'm actually in Windows at home is to play video games, because I do everything else in Linux. So lo and behold, I was trying to find how to finish some quests in Skyrim and went to Skyrim Wiki, and suddenly I had fake AV on my computer. I was like, you bastards. Yeah.
Sure.
The one time only that I've actually gotten an infection on the computer is because of a video game. No, I'm not kidding. I'm serious. And I can do backups of this.
Ours is like number 9 or number 10, right? Sorry.
More like 3 or 4. Sorry. Yeah, backups. And now I can actually have a disk image that is read-only to a whole bunch of Linux boxes booted off over iSCSI, where I can patch that and have everything else updated. But this really got started from seeing something that Doug was talking about on Twitter, doing malware incubation. So my concept was, I've got this thing with like virtual machines where I can thinly provision stuff and spin up a whole bunch of virtual machines, but there are some pieces of malware out there that recognize that they're in a virtualized environment. So this is running on bare metal. The only difference you see on this is the hard drive controller, and it's the Microsoft iSCSI initiators, or under Linux, it just looks the same. You've got dev SDA or whatever. Question?
So you said if you, as long as you don't have caching on, you can actually update the drive on the server and then have the clients like.
So for the read-only file system stuff on Linux, I haven't actually implemented it over iSCSI. I've done it with NFS. I don't know how the caching is with read-only stuff over iSCSI. I get the impression that suddenly blocks being updated on the disk underneath of the kernel might confuse it, even though it's read-only. But I primarily would use it for inspecting a hard drive while a machine is running to see what's going on, because now I can do that. Before I couldn't do that by like man-in-the-middling a SATA. Stop it! Like SATA cable or something. Okay, and that's it. Any questions? I hate you, EPC. All right, any questions? I've blown all of your minds. Okay, all right, thank you. You? No? Okay.
Waxen was walking.